My next formula is the multiplication rule number 2. And it states that the probability of event A and B is equal to the probability of A times the probability of B, given that the event A has already occurred. Now what we want to include is the definition of the dependent event. So this formula will only be applied when two events are dependent. This is one of the rules that's on your formula sheet. What we're going to do is we're going to continue on and follow through a few examples. My first example is 4-28. For a specific year, 5.2 of U.S. workers were unemployed. During that time, 33% of those who were unemployed received unemployment benefits. If a person is selected at random, find the probability that she or he received unemployment benefit if the person is unemployed. The most important thing here is to be able to read this and write this down in symbolic notation with probability symbols. So I'm going to read this one more time and I'm going to write stuff down. For a specific year, 5.2% of U.S. workers were unemployed. So I'm going to say unemployed is going to be labeled by U, and the probability of being unemployed is given to me at 5.2%. So I'm going to write this at 0.052. So this is my 5.2%. During that time, 33% of those who were unemployed received unemployment benefits. So I'm going to give it another label. Benefits, I'm going to label as B. Now that one is given to me at 33%, but 33% of those who were unemployed. So the probability that was given to me is the probability of receiving unemployment benefits given that this person is unemployed. So this would be the correct notation. If you write down the notation correctly, the formulas will aid you the best or the most. I'm going to continue reading the problem. If a person is selected at random, find the probability that he or she received unemployment benefits. So I'm interested in the person who receives the unemployment benefits if the person is unemployed. So what they're looking for is the person is both unemployed and receives the benefits. The formula states that what we need is the probability of U times the probability of B given U. As far as the AND statement is concerned, this is commutative. You can switch the B and the U in places, and the reason I'm using it the other way around, so let me rewrite this so it makes a little bit more sense according to the formula. You see, I'm jumping, I'm looking at this formula, I'm looking over here. So I want the probability of U times the probability of B given that U has already happened. I'm rewriting the U and the B because what is given to me is B given U. If I have this formula right here, I'm pointing to this one. If I have this formula right here, that means that I want to write this down this way. That way This is just 0.052. This is just 0.33. And it becomes a calculator problem. I'm just taking out my calculator. And 0.052 times 0.33, rounded correctly to 4 decimal places. I have 0.017, and then I have 1/6, so I can either write it as 1/6 or a 2. Let's take a look at another example. I'm looking at example 4-30. Where the 3 cards are drawn from an ordinary deck of cards and not replaced. So card is drawn and not replaced. Find the probability of the following events. So my part A, I need the probability of getting 3 jacks. When I'm talking about 3 jacks, I need the jack, and I need another jack, and I need another jack. Let's start with the first one. How many jacks do I have? I have 4 jacks. My sample space is 52, so the probability of getting the first jack is 4 out of 52 times. Now, if I'm not replacing the card, that means that I have a jack in my hands, and now the deck has 3 jacks and only 51 cards. So the probability of getting the next jack is 3 out of 51. Now, if I have 2 jacks, now there's only 2 that are left in the deck, and only 50 cards left in the deck. So what I end up with is this. So the probability of getting 3 jacks is very small. If you take out your calculator and start multiplying this out, 4 out of 52 times 3 out of 51 times 2 out of 50, you will end up with scientific notation. Now my calculator spits out this. 1.8, then there's a 0, and then there's an e to the power of -4. What you want to do is you want to multiply this by 10 to the power of -4. This is a scientific notation. Do not put little e because that is calculator notation. Let me do the next problem. Getting an ace, a king, and a queen in that order. So I need the ace, king, and queen. The probability of getting an ace is 4 out of 52. Now, if I'm not replacing the card, the probability of getting a king, there's still 4 kings, but there's only 51 cards. Now, as far as the queen is concerned, I still have 4 queens, but there's only 50 cards left. So I can do this one. This shouldn't be too much different from the previous one because I'm still working with very similar small numbers. So I have 4 out of 52 times 4 out of 51 times 4 out of 50. It approximates to 4.8 times 10 to the power of -4. Great. Getting a club, a spade, and a heart in that order. Very similar problem as before. We have 13 out of 52, 13 out of 51, and then 13 out of 50. And the last problem is getting 3 clubs. Very similar to the first one. 13 out of 52, 12 out of 51, and then 11 out of 50 because I keep getting clubs. Another example that I wanted to show you is on the next page. It's 4-31. A box contains 2 red balls, 1 blue ball. Box 2 contains 3 blue balls and 1 red. A coin is tossed. If it falls heads up, a box 1 is selected and a ball is drawn. If it falls tails up, the box 2 is selected and a ball is drawn. Find the probability of selecting a red ball. Now, if you have a few events that are interconnected like this, one of the tools that you want to use in order to create your sample space is a tree diagram. So your first event is tossing a coin. Tossing a coin has two outcomes, heads or tails. So this is what I have to start with. There is a 50% chance of getting heads. And the probability of tails is the same. Now, if I'm getting heads, I am selecting box 1. If I flip tails, I'm selecting box 2. Now, box 2 contains let me start with box 1. Box 1 contains 2 red balls, I'll fill in the bottom in a second, and 1 blue. Now, because there's only 3 balls in here, so the probability of getting red here is 2 out of 3. The probability of getting blue here is 1 out of 3. I'm just concentrating on box 1. Now, box 2 also has red balls. It has blue balls. Box 2 contains 3 blue balls and 1 red. 3 blue balls and 1 red. Now there's 4 balls in box 2, so the probability of getting a red in the box 2 is 1 out of 4, and getting the blue ball out of box 2 is 3 out of 4. I'm just concentrating on box number 2. Find the probability of selecting a red ball. So now this is my final question. My sample space is now complete. Now I have to figure out probabilities and give the final answer. Find the probability of selecting a red ball. I'm going to take out my highlighter and I'm going to outline the 2 events that I'm interested in. I need to flip heads, select the box 1 and get a red ball that way, or I can flip tails, select box 2 and get a red that way. Notice, this is a tree diagram. If you follow a tree diagram, you multiply each branch by each other. So what you have is you have a half that's being multiplied by 2/3, which is 1/3 right here. And then you have a half multiplied by a quarter, which is 1/8. Let me move this just a little bit on the bottom, to the bottom. So therefore, the probability of getting a red ball is therefore 1/3 plus 1/8. I do assume that you are comfortable with fractions. If you need your calculator, please do that. If you want to leave your final answer in a fraction, that's great. If you want to leave your final answer in a decimal form, please make sure it has 4 decimal places.